Hi, hello. This is Shashank Raoji from the Aeronautical Engineering branch, semester 4 of rule number 47. This is a Tech Talk video presentation for the subject aircraft propulsion, and the topic is combustion instability in ramjet combustors. Understanding and mitigating combustion instability in ramjet combustors. In this presentation, I aim to understand and mitigate combustion instability in ramjet combustor, explaining what is ramjet combustor. We will explore the causes, effects, and potential solutions for this critical issue in aerospace engineering. Ramjet combustion bills. Actually, what is a ramjet combustion? It is a propulsion system of an aircraft in which there are no compressors, but uh, the the airflow is compressed due to high decrease in area ratio and high speed, and it is also used in high velocity and high Mach number levels. The Mach number in the combustion chamber is less than 1, and the Mach number in inlets and nozzles are greater than 1. Ramjet cannot only be used while performing a mission profile in an aircraft because it requires a high Mach number for the combustion, which cannot be achieved at takeoffs and landings, which is why we use other propulsion systems while low Mach level Mach number levels. Understanding the thermodynamics and fluid dynamics of ramjet combustion is crucial for understanding its instability. The interaction between airflow and fuel injection plays a key role in the process. In the combustion chamber, the fuel is injected at Mach level less than 1, and the airflow at the inlets is greater than 1. The, the velocity is higher. The velocity is higher at the inlets than in the combustion chamber, and due to the area ratio, there is a decrease in the Mach number and the velocity. Causes of instability. Factors such as flame holding, pressure fluctuations, and combustion resonance can lead to instability in ramjet combustors. Flame holding. Yeah, as I've earlier told, the ramjet combustions cannot be performed or utilized at the phases of takeoff and landing. When the aircraft has achieved a higher Mach number, ramjet comes into operation and there needs a good flame holding for the combustion to start. While there is a gradual decrease in the velocity and gradual increase in the velocity and gradual decrease in the area, there might be a large number of pressure fluctuations throughout the combustion propulsion system. This causes an instability in the combustion chamber. And one more greater reason for this instability is combustion resonance. Effects of combustion instability. Combustion instability can result in flame out, excessive vibrations, loss of performance. Flame out. Due to high speed airflow in the combustion chamber or through the inlet, there are lots of chance of lots of chances that the flame gets ignited off, and which may lead to no combustion in the chamber, and there needs to be more fuel or more spark or excessive flame to be allowed in it. Excessive vibrations due to high pressure fluctuations in the combustion chamber or the ramjet propulsion system. There might be excessive vibrations system, leading to the structural damage too and loss of performance. Because of this combustion instability in the ramjet propulsion system, we may lose aerodynamic performances and aerodynamic characteristics, which in turn loses the efficiency. These effects can compromise the safety and efficiency of ramjet engines. When there are excessive vibrations in the ramjet propulsion systems, it leads to structural damage. In turn, the safety of the engine and the efficiency is decreased. Diagnostic techniques. We've observed the causes and the effects of the instability of the instability of the ramjet combustion chamber. Let us go through solutions and few diagnostic techniques to resolve the problem. Various diagnostic tools such as pressure sensors, spectroscopy, and high-speed imaging are used to analyze and understand combustion instability in ramjet combustors. Pressure sensors are placed in via various parts of the ramjet engine, such as inlet, nozzle, combustion chamber, etc., to understand and determine the pressure all over the body and optimize it. Spectroscopy and high-speed imagings are also used to analyze and understand combustion instability in ramjet combustors. Mitigation strategies. Effective damping methods, fuel injection control, and geometric optimizations are key for mitigating combustion instability in ramjet combustors. These approaches aim to stabilize the combustion process. Fuel injection control. The fuel is injected in the combustion chamber, and due to higher pressure differences or high Mach number, the fuel injected can be disturbed or the fuel vapor cannot be properly mixed with the airflow because of its high speed. A controlled fuel injection might lead to a solution for this instability, and the geometric optimization of the nozzle and inlet and the entry of the combustion chamber can a lot help the to solve the problem. There is a greater difference in the area ratio from inlet to the combustion chamber, which is why it is used to compress the airflow without any compressor or compressor blades. Experimental validation. Experimental testing and validation of mitigation strategies are crucial for assessing their effectiveness in real-world ramjet combustor environments. These tests provide valuable data for refining mitigation techniques. As we've seen, there are lots of mitigation techniques and diagnostic techniques to resolve the problems of this instability in the ramjet propulsion systems. But coming to their validation, it must be experimentally approved before getting into the actual aircraft. Because, like, if we can use a wind tunnel experiment or many such experiments to validate the working of the ramjet with a good geometric optimization, good fuel injection control, pressure sensors, and high-speed imaging techniques. Once we put it in the wind tunnel, the propulsion systems, we can gain a lot of information, and we can again optimize it for better validation and better performance of the propulsion systems, which in turn increases the performance of aircraft. These tests provide a valuable data for refining mitigation techniques. Computational modeling. Advanced computational fluid dynamics, CFD, simulations are used to predict and analyze combustion instability in ramjet combustor. These simulations aid in understanding complex phenomena of the flow. If we perform an advanced CFD simulations of the for this propulsion systems, we can gain lots of informations rather than just by wind tunnel experiment and normal experiments. CFD is about better better alternative for such experiments. Future research directions. Continue research in advanced materials, control systems, and alternative fuel formulation. Holds promise for further advancements in mitigation. Future research directions. Continued research in advanced materials, control systems, and alternative fuel formulation hold promise for further advancements in mitigation combustion stability in ramjet combustors. If we use some advanced material for the structural components and control systems and alternative fuel formulations, there is a need of alternative fuel formulations for the ramjet combustors because the vapors might not properly get mixed with the air as the air in the combustion chamber is at high Mach number. Though it's less than one, it has a high Mach number, and the fuel vapor might not get combusted properly. So there is a future need for future research in these segments. Industrial applications. The knowledge gained from addressing combustion instability in ramjet combustors has broader implications for aerospace, defense, and propulsion technology. These insights can enhance the performance and reliability of various systems. In conclusion, understanding and mitigating combustion instability in ramjet combustors is essential for ensuring the safety and reliability and performance of these critical propulsion systems. Continued research and innovations are crucial for addressing this complex engineering challenge. Thank you.